So a while after X-rays were developed, medical imaging researchers started wondering about how to take images of the body that were not limited to just one plane of vision. One thing that is quite obvious about an X-ray is that it's like a 2D photograph. So over on our knee X-ray video, or our knee X-ray from the old video, this is just a frontal plane image of the knee, right? So planar 2D image. Advances in imaging technology allowed doctors to start taking 2D slices using something called computed tomography, or CT. So a CT scan is like X-rays. Well, it uses X-rays. It's X-ray based. Let's write that down. And it takes slices of the body. These were formerly referred to as CAT scans. I mean, sometimes people still call them CAT scans today. Technically, that term is a misnomer now because this stood for computed axial tomography, which meant that you were only able to take axial slices of the body. So in this image right here, which is, I guess, getting crowded by the one next to it, this is an axial slice of the body. You might remember axial. That's sort of medical imaging equivalent to transverse plane. So back in the day, you could only take transverse plane slices of the body. Today, you can take CT scan slices of the body however you want. This is a CT scan of somebody who has a pretty messed up knee. That is not supposed to be broken. This is a tibial plateau fracture, I think. And the CT scan, you can see, gives us a much better look at what's going on inside the bone. So this is not a projection of the whole knee. This is a individual slice inside. So the X-ray sort of collapses the whole three-dimensional image of the bone onto one planar image. It's like we're taking all the slices of the bone and we just squish them together. The CT scan allows us to slice through the bone, like step by step, however we want to look at it, in any plane of motion. So that's super convenient. Another thing you can do with CT is you can take those slices and you can stack them back up. So suppose we did take a bunch of transverse plane slices of the tibia and the femur like this. You can see in this 3D image, there's this kind of modeling, stippling, rippling here. And that's because this image was created, or this 3D model, I should say, was created by stitching together adjacent slices from a CT scan. So by doing that, you can get a three-dimensional model of the bone. So this is very popular for planning surgeries for things like femoroacetabular impingement, which is a deformity of the hip, which I think I put in the problem set. It is also popular for looking at children with developmental musculoskeletal conditions like cerebral palsy, who often have a misshapen bone structure. So maybe their tibial plateau will not really fit very well into the trochlear groove here. Super useful for getting a really, really detailed 3D picture of what's going on inside the body. They're also really short. So let's see, pros of CT scan. Fast, they're really fast. It's like 5 minutes, maybe 5-10 minutes. High resolution. You can get really, really, really nice image of what's going on inside the body. You can see more than just bone. Although it is most often used for bone because one of the other benefits of CT scans is that you can measure bone strength. Let me write that out and then explain it. So one of the consequences of the fact that you can take slices of the bone is that you can, by measuring how much of the x-rays that you're bombarding the bone with get absorbed, you can measure how strong is the bone, meaning what's its density, like how much calcium is there. So if you do a CT scan, you kind of get a DEXA scan for free. We'll talk in a few moments about what a DEXA scan is. But these are all nice advantages to the CT scan. How about disadvantages? Well, let's write con. So pros and cons. Expensive. Also, more radiation. So more radiation than an X-ray. As you might imagine, to get all of this detail, you do need to bombard the body with a lot more ionizing radiation. So again, don't really want to be doing these willy-nilly. 1, 2, 3 CT scans, not a big deal, but this is not the kind of thing that you would, there's a reason why, for example, they don't do these on kids who get concussions, because you don't want to be bombarding your brain with radiation all the time. Okay, so that's CT scans. These are fast. They're really high resolution. They can allow us to image more than just bones sometimes. And the fact that we're using x-rays allows us to measure the strength of the bones. However, they're expensive, and they do involve not just ionizing radiation, but more ionizing radiation than your typical x-ray.